Hey, I am gonna do a little video about this page, okay, about the water analogy. Electrical circuits are somewhat, it's not quite as intuitive because you can't actually see charges, but so that's why we're gonna give you a lot of different analogies in this unit to think about. I think one of the best analogies is the water analogy. So you can think of charges moving through a wire like water moving through pipes. So imagine you have a pond up here, you have a pond down here, and the reason that water would flow is there is a potential difference from here to here. Well, that's the same thing with electrical stuff. That, hey, I have a battery. If I connect this side and this side, from here to here, there is a potential difference across there. And you might think like, no, I'm not getting shocked right now because I have a super high resistance, okay? But yeah, there is a potential difference. In fact, this battery has a 1.5 volt potential difference. This also has a 1.5 volt potential difference. This also has a 1.5 volt potential difference. This has a 6 volt potential difference. This has a 9 volt potential difference. But more on that in a little bit. But yes, if there is no potential difference, water is not going to flow. This setup is, so again, why do we want electricity to be flown? So that we can do something with it. So those charges moving, we can use that electrical energy to do something, like light a light bulb, like cause a motor to spin, like run our stereo, whatever it is, okay? So if I want to have something that's going to use the charge, well, that would be a water wheel. And so here is my beautiful water wheel. And yes, I did minor in art. There's my beautiful water wheel. Now you might think, well, why did I put the water wheel there? Well, I'm not going to put the water wheel in the middle of a pond because charge doesn't flow here. Why? Does charge not, or water, why does water not flow from there to there? Because there's no potential difference. Here, there is a potential difference. So this resistor, that's the resistor, okay, is my water wheel, is making it harder for the water to flow. What is a resistor? A resistor makes it harder for electrical current to flow, okay? But really, the resistor is the thing that's useful. It is a light bulb. What is it doing? It's using that electrical energy to turning it into light, okay? But this circuit is going to have a problem. Why is it going to have a problem? Because you're going to run out of water. So what are you going to have to do? Well, you're going to have to pump the water back up to the top. So let's draw in our pump. So that the water would be flowing like this. Hey, I now have a water circuit. In fact, the word circuit means to go around. So if you have an electrical circuit, that means the charges can go around. So this pump is like your generator. This pump is like your battery. It is what is sustaining that potential difference, okay? Hopefully that makes sense. Hopefully you have a picture that looks like this. Other questions on that stuff, just to make sure, that you have it. Current is measured in amps, okay? Current is measured in amps. 1 amp is 1 coulomb per second. Remember, okay, this doesn't mean that the charge is zipping along. It just means that you're getting lots of charge per second, okay? 1 amp is a scary amount of charge. In fact, 0.07 amps going through your heart, that's enough to kill you, okay? If you had 1 amp going through your hand, you are not going to use your hand anymore because it's going to be burnt to a crisp, okay? But current is measured in amps. It is a coulomb per second. In fact, on your equation sheet, it is written like this. I think they write it change in Q over change in time. I think that's how it's written. The units for voltage is, surprise, surprise, is going to be a volt. But this is important. A volt is a joule per coulomb. Okay. And I'll talk a little bit about that in a minute too. And then the unit for resistance is an ohm, like ohm, yeah, which has the symbol like this. So amps is a symbol A, V for volts, and omega, it's a Greek symbol, but you can think of it like a horseshoe. is going to be for resistance. All right, I'm going to pause and then I will show you another video dealing with this as promised. Bye, kids.